Okay, hello everyone. Today in the FHE Onchain podcast, we're having Joe and Erin from Optalysys, and we will be talking about, in general, confidential compute, FHE, and the other privacy protocols, and what Optalysys does in as detailed as possible. And I hope it will be a great episode. So yeah, welcome Erin and Joe. And it would be great to start with your at least a slightly intro to your backgrounds, who you are, what you are doing in Optalysys.
Thank you, Furkan. So, Erin, would you care to introduce yourself first?
Yeah, of course. So my name is Erin Hales. I have a background in maths and I am nearly done with a PhD in FHE. So in my PhD research, I've been working on mostly CKKS and BFE, BGV, those type of schemes, and also on security standardization for FHE. Yeah, so that's how I came to be at Optalysys, and my role there is as a cryptography researcher. So I'm continuing a lot of the work that I was doing in my PhD, while also seeing how that fits in with the Optalysys products and other projects.
Hi, and I am Joe Wilson, Head of Strategic Innovation at Optalysys. I've been with Optalysys for about 5 years now, and Optalysys is an optical computing company. We have always existed with a remit to do optical computing and a very specific kind of optical computing. And what we found over the years is actually that the kind of computing that we do is a very, very good fit to the field of FHE. So we are now working to create a product in that space that actually incorporates the benefits of optical computing.
Yeah, it sounds great. So, first of all, I'm wondering about Optalysys in general, what Optalysys does, and it would be great if you could tell us a bit about Optalysys, and maybe we can start with you, Joe, this time.
Okay, sure. So, Optalysys, as I said, it's always been an optical computing company. Optalysys was formed in 2013, specifically with the remit of taking a very specific branch of optical computing out as a digital coprocessor. So prior to that, people have always used this particular kind of optics to solve certain problems in things like pattern matching. We're talking about the field of optical correlators, and that's a technology from the 1960s. In 2013, Optalysys was founded to take that kind of optical processing, but actually bring it proximate to the digital domain. So being able to use optical compute, specifically Fourier optics, if you've ever heard of the term, and use that as a coprocessor for digital systems. And there are some significant advantages to doing this. So I'll spare you the really gory details in the maths, but essentially optics will do a very particular math operation that is very useful across many different domains. It will do that instantaneously, and it will do that algorithmically in a much more simplified way than you would do it in a digital system. And as luck turns out, that particular operation that we're doing in optics is also really central to doing processing in FHE. So we're talking about transform operations, and these are used very heavily to enable efficient multiplication, especially in FHE schemes. So putting the two together, you have some 70 to 90% of your workload in FHE is occupied solely on doing these transforms. They are a significant and key bottleneck in FHE workflows. And on the other hand, you have very fast, very efficient optical computing that can fulfill that need. So the two kind of mesh together really nicely.
When we say optical computing, what first myself, then our viewers should understand from that?
Yeah, so in regular computing, and Erin, do feel free to sort of kick in there if I say something incorrect here, but in regular computing, you're dealing with ones and zeros, you're dealing with binary, you're dealing with transistors. In optical computing, your phenomena on which you are computing is different. So in digital computing, you are primarily using silicon, semiconductive silicon. In optics, you're actually using the properties of light, as in light will naturally do the same maths that you would otherwise be looking to do in a digital system, but it will do it as a property of itself. So the advantage there is that you're not having to replicate anything through ones and zeros. that is actually an emergent property of the universe itself, and it is very, very fast. So there are some very significant advantages if you can get light to do the kind of computation that you want it to. And that's not a universal thing, or at least not at the moment. There are no all optical CPUs, but for certain operations, so obviously Fourier optics, the kind that we deal with, but also certain operations in AI, so multiply and accumulate, those can also be done in optics. And the benefit there is that, again, you get very, very high speed with regards to processing, very low energy consumption, because optics is entirely passive, very low heat generation from the actual core operation itself as well. So this is why optics is actually a very, very powerful technology if you have an application that can leverage the way that it can be implemented at the moment.
Yeah, it's really interesting. Like I'm like though even like though I'm a senior math student. Like my first major was physics before heading to double major. So like it was quite interesting to me like to hear optics here because like honestly I hated it always. Compared to mathematical stuff, I hate experiments, and so I mean it's interesting to hear optics even here while talking about cryptography. But it was a great intro. Thank you. Yeah, next question is for Erin, and I always love to see mathematicians here. I mean, that's a great pleasure once again. And like when we say FHE, of course, there are different schemes, right? Like, and different products use different schemes. And in the blockchain space, it's mostly TFHE because of the TFHE RS and FHE VM libraries. And when it comes to AI, as far as I know, it is mostly CKKS, right? So asking from like Optalysys perspective, is there any particular scheme that you're focused on like to use and build top of that, or it's a bit more like scheme agnostic?
Yeah, so that's a really good question. So I'll do my best to answer. I think maybe a good thing to start with talking about is the differences between the types of schemes. So the first thing, if we classify them a little bit, we can sort of explain the benefits of each one for each thing. And like you said, the sort of AI uses versus blockchain uses. So the two types of schemes come in sort of two main paths. One of which is the BGB, BFE, CKKS. If you don't love acronyms, it's completely fine. This type of schemes, they're leveled, which means that they consume, by doing operations, you consume levels. And the other type of scheme, which is FHEW, DM, and TFHE, these guys work with something called bootstrapping. So the main difference between these CKKS and TFHE is that CKKS can work with approximate data. And CKKS is designed to work with approximate data. So this is where the AI machine learning use case comes to the fore, because if it's designed to work with that type of data, then it's naturally well placed to work in AI where there's a lot of that kind of data about. TFHE is better at sort of integer or binary computations. That's with ones and zeros. And yeah, so the two different schemes. First of all, CKKS, it has the ability to compute in parallel very well. This is called single instruction, multiple data. Sorry, and so you give one instruction, you can evaluate it over tons of stuff at once. So this gives it some advantages. TFHE, on the other hand, is very quick to evaluate, but doesn't have this same availability to evaluate on lots of things at once. So if it's very quick, this makes it ideal for blockchain stuff, especially the ones and zeros situation. And also, it's because it's able to evaluate very quickly and not in parallel. Well, in lots of blockchain smart contract type use cases, you actually don't need this parallelizable aspect because you want to do things in series in this world. So the other thing is that the work of Zama, which I think you have some other podcasts about, has been integrating this FHE VM. So integrating products based on FHE and specifically TFHE with existing things, Ethereum, in the blockchain world. And so this sort of partnership and the work that's been done to make these compatible is really good in this respect. So what we are hoping to do at Optalysys, the technology that we have is not specific to any one scheme. The transform that we accelerate is present in all schemes. And therefore, we are not specifically accelerating TFHE or CKKS. That being said, due to the nature of TFHE being well suited for this application and the work that's already been done in the
And I'm wondering, like, the target audience of the Optalysys. Okay, when it comes to FHEVM, it's quite simple. Like, target audience are developers mostly, and like building decentralized applications on top of these private blockchains. When it comes to Optalysys, what is actually the target audience? Is it again developers or like a different kind of businesses? And I know in what ways Optalysys leverages like the encryption technology, in our case FHE, to get more get more to its target.
Sure. Do you mind if I take that one, Furkan?
Yeah, sure.
Yeah. So we are a hardware company, as in we are right at the bottom of the stack. We are physical layer infrastructure, and we are developing these specialist systems are specifically targeted towards FHE. Now, the core optical technology that we develop is actually applicable outside of this field. It just so happens that it's also a really good fit because it solves a problem in a way that you're not going to solve with digital systems. We know how fast digital systems are. We know how fast they can be. We know how fast it's going to be once you've made the adaptations in digital to actually create an accelerator. You know, there's a lot to be done, but once you've done it, where do you go from there? Optics, to my mind, has a significantly greater headroom for improvement. I mean, certainly in terms of the way we do things now versus where that we can take the technology to process data even faster. For FHE, that has a very, very significant knock-on effect. And this is why we are working so hard towards an accelerator, because we can hit targets that I don't think you could hit in digital at all. So our audience for that, in terms of who you might think our frontline audience are obviously the people who would actually be deploying FHE. Now, that could be if you are looking to acquire nodes for participation in some of these FHE-enabled blockchains. It could be at the hyperscale, where, you know, rather than buying the nodes yourself, you want to use infrastructure. The infrastructure provider in that case would be someone relevant to Optalysys. But obviously, FHE is a very new field, so we do an awful lot of work in partnership with people because we see that as a way of driving the market, driving the technology. It gets us incredibly useful feedback from our potential customers, and it allows people to actually see and understand how this new era of blockchain is going to work. We do an awful lot of thought, not just about our hardware, but about the landscape that we're actually selling into. And so we do a lot of partnership. We do a lot of collaborative work with people.
Yeah, thank you for like this broad explanation. The other question is of course like related with more like blockchain side, and like blockchain. Like, I mean, there are of course like dozens of potential use cases of FHE for the future, but like due to the very popular reasons regarding FHE, most of them are not practically possible for today. But I personally believe that blockchain side is like, you know, more practical than the other, like, let's say AI or like confidential healthcare stuff, because like, especially in like payments or like basic token transfers, the data to be encrypted is not that big, so it's like, let's say, more feasible to deal with in a as an L2 or as an L1, providing confidentiality to other blockchains. And there are a couple of examples of them during testnet stages in the industry. Like the solution Optalysys, you know, working on, like how it would enhance like the blockchain aspect of for blockchain users.
Sure. Yeah. So I guess if you think about like FHE is slow is kind of like a stereotype, I think,
Yeah.
that I definitely heard a lot when I was in the academic world. But I think if you look at like the performance improvements of FHE over time, especially with all of these, so I started my PhD in 2018. So during the time that I was doing my PhD, basically FHE went from being kind of like, oh, that's fun, to being like, oh, people are doing that in the real world. So I guess like from my personal perspective, I see like a lot of the blockchain applications as like a way of getting other people involved in FHE and using FHE and interested in it, and it going from being this kind of niche thing that like some people are interested in to having this like broader application and use case. And I think the more people are interested in using this technology, the more people working on it, um, you know, the better. So the more the community builds and the more people are researching it, thinking about it, looking at all different aspects and finding applications. Because there may be someone has some cool application they're thinking of, like, oh, well, maybe you could do this with this. And no one's thought of it yet. And then this could be the next big thing, and we don't know yet. So I guess going back to the sort of Optalysys point of view, if we have like the hardware, this accelerates anything you want to do. So then for people who want to build on top of that, they can kind of, yeah, accelerate whatever it is that they want to do. And it's kind of up to the communities, and then we can hopefully make that faster for them.
Like,
Yeah.
sorry, like
Sorry. Go ahead, Furkan.
just a follow-up question.
Yeah, of
So
course.
then, like, do validators use these like Optalysys hardware to accelerate FHE on blockchain, like at the end of the day, or do you guys have another infrastructure idea to use in blockchains? Because like when it comes to hardware, I mean, someone has to use it, right? And there are some parties in blockchains like users, validators, full nodes, light nodes. So in our case,
I
we're
think you might be better at this one,
Oh, okay.
but
Yeah.
I'm not
So
sure.
So a lot of the time, we're looking at, obviously there are a number of different ways of doing FHE on the blockchain. So we know that, for example, Inco are looking at sort of like an L1 solution. Other people are looking at things like L2 solutions. So, sort of using roll-ups to reconcile things back to the main chain. So at the end of the day, the hardware in this space, if you're doing FHE operations, it's predominantly governed by having to do FHE operations. So a singular sort of product, like essentially a node design, we see as something that, that would be a first product for us. And then we could potentially go back and forth. We can reconcile with regards to what the field wants. I mean, in terms of how FHE, as Erin says, is perceived right now in terms of speed, we've always seen speed as kind of a misnomer. I mean, yes, okay, FHE is slower if you want to be able to do certain computations within a certain fixed number of block times. For example, you are going to need some, reduced latency. Actually, what we see is scalability, and specifically commercial scalability, is the really big driver for this, because nobody ever said, oh, actually, that's cheap enough. Thank you. Nobody ever said, oh, actually, that's fast enough. So even though, as you say, blockchain is something where the kind of transaction processing, the kind of individual operations you need to do are not, by the standards of FHE, remarkably intensive, you're still going to want to do those things. If you want the market to grow, if you want to be able to build more complex applications, get more people using it, designing new solutions for things, actually, if you're looking to the future, you are going to need some way of making this either cheaper, faster, both. And that's really where the hardware comes in. So obviously, people work a lot in the Ethereum ecosystem nowadays. If you're looking ahead to a world where you could potentially be like a payment layer, like a very high speed instant reconciliation payment layer where you want to maintain privacy in that space, or you're looking at other applications that need very high throughput, that's where an accelerator becomes non-negotiable. Certainly compared to the way things are done right now, because you already have to use fairly intensive high compute capabilities to do FHE in Ethereum blockchain. Into the future, you're going to need a solution for that. Something that goes beyond the limits of regular computing, that's for certain.
Yeah, thank you. And I have one like more cryptography related question. And I'm like having this question a lot in like a small events in my country when I like in a cryptography events after like and in general I'm being like the only speaker talking about FHE and like people asking like I mean the first question of course is about the speed and the second question like sometimes is about like the quantum resistance of FHE because of the last year's lattice incident, let's say. uh, and like it was a horrible 2 weeks even for me because like it was like one of my first months in FHE and like that paper came out and thank God it like the things settled and now we're still saying FHE is quantum secure because of the lattice-based cryptography's hardness assumptions. But of course there is no guarantee that tomorrow there is not going to be a new paper finding a polynomial time algorithm to break lattice problems. So do you think we have like enough work like or enough researchers working on that as well? And due to the fact that all the existing FHE schemes are based on learning with errors and lattice cryptography, when its security has a trouble, how will
Erin, I think.
Yeah, I will do my best to answer this question. Yeah, so I was also in the FHE space at the time of the release of this attack, so I had my own anxiety around that. I guess, like, the question is really about the research community. It's not sort of specific to like what Optalysys is doing. So
yeah
I can answer
totally.
this pretty much from my background in academia and sort of FHE research space and lattice security. Yeah, so it's a lot of my perspective that's going to come out here. So what I would say is that had Chen's attack succeeded, it would have only affected certain FHE schemes due to the parameterization for which it would have applied. So Nigel Smart had a really nice blog post about this at the time, in which he basically said, well, don't worry, this is only going to apply to one particular scheme. And this is often the case with attacks. It's very rare that an attack blows something entirely out of the water. It's much more common that it sort of affects a particular parameter case or a particular situation, and you can kind of mitigate it by changing your parameter settings. And so some schemes might be vulnerable more so, some schemes perhaps less vulnerable. But yeah, so this is one of the things that I would sort of say on that point. The other thing is, in order to carry out Chen's attack, had it been successful, you would have needed a quantum computer. And we don't have one of those yet. So this would still be, I mean, ever since I took my first class on quantum computing when I was an undergrad, far too long ago, quantum computers were 5 to 10 years away, and now it's been far more than 10 years since then, and they're still 10 years away. So I would have these as caveats when thinking about these things always. I think people have a real tendency to panic a lot about this. And I mean, justifiably so. Like, we ought to be worried about security, and I really hear that. I think people do tend to panic. The other thing I would say about lattice security, so it's not like LWE is something that just was plucked out of the ether and it happens to be used a lot in FHE. LWE as a hardness assumption is used in a lot of different cases. And there's a lot of cryptography outside of FHE which is working with this. So if you've been following the long NIST standardization process, this is part of the US government, has been standardizing post-quantum cryptography for a very long time. And many different schemes were submitted as part of that process and have been studied for a long time as part of that. The lattice-based schemes have been pretty successful in that. And many schemes were scrutinized very heavily as part of this process, and some of them broken. So what I would say is, like, this additional study from the community should give us kind of more faith in lattice-based schemes as a whole, given that, well, they've been scrutinized, we've had attack scares, and we're still going. I think would be something, at least. Yeah, as I was writing up my thesis at the time of Chen's attack, I was like, am I gonna have to like say something different about this? Yeah, so that would be my perspective. Lots of things have happened in the learning with error space, and we still have security reductions. We still have hardness guarantees. We still have the lattice estimator to help us choose secure parameters. And there's lots of tools and research to help us stay secure in this space.
Yeah, actually, that was a great answer, and like I wanted to ask this question on purpose, just like to make our viewers hear the fact from some other person. And yeah, thank you so much. So let's get back to Optalysys then. I'm not an expert on like the hardware stuff and like what's going on in the industry, like doing hardware research and productions. But as far as I know, there is a couple of different companies doing hardware stuff to accelerate FHE or like to do something differently. What makes Optalysys different? From your perspectives, and maybe we can close the episode with this question.
Yeah, so the thing that makes us different to almost all computing hardware is the optical angle. As in, that is a very specific thing, even within the field of FHE. That is a very unique thing. Now, if you look at other examples out there, so if you look at some of the academic papers around other hardware accelerators that came out, things like the DARPA DPRIVE program, for example, you look at things like Basilisk, and I think it's Trebuchet as well. If you look at anything where FHE was the goal, you typically tend to find a certain select set of sort of approaches. And chief among them is the fact that all of these systems are effectively a very large transform processing pipeline in digital systems to allow you to do that multiplication. These operations really are predominant in FHE. And this is obviously where I introduced earlier, where this angle from Optalysys comes in is, you can actually do the same maths, and we do the same maths. So using an optical system, the way we do our optics in silicon photonics is it is intended to be such that you would get the same result out of that system as you would out of a pure digital system. So that questions about things like, is there excess optical noise? Does that change the way you need to do things? Does that change the schemes you need to use, or do you make modifications? None of that. Okay, so everything we do is compatible with the existing FHE libraries, the existing way of doing things. And we also support NTTs specifically in optics. So obviously Fourier optics mainly deals with complex domain Fourier transforms. NTTs are far more prevalent and common in FHE because obviously it's all number theory under the hood, and NTT, number theoretic transform, does exactly what it says on the tin. It transforms things over an integer field. So that is the focus of what we do in the optics. It is very similar to what you find akin to other hardware. It's just that the speed and the energy consumption are not things that you can access, even using very powerful sort of like new nodes from the likes of TSMC. The kind of speeds you can achieve in optics in terms of being able to feed data into those systems is vastly beyond what you can achieve in silicon. And that really is what makes Optalysys very specifically unique. It is a singular aspect of the system, but it is absolutely key to being able to do this kind of thing at speed, at commercial scale.
Of course you guys have some docs and like maybe even like blog posts, but I would love to hear some additional resources and to like for both our listeners and myself to go to find out more about Optalysys and the underlying technology. It would be great if you could recommend some additional resources to like the documentation.
Certainly. So obviously, shameless plug here for our own website and our innovation lab. But if you go to www.optalysys.com, then you will be able to find links to our innovation lab, which is where we have a centralized hub of information about Optalysys, about FHE. You can sign up for that and get access to things like, our own set of webinars, our own sets of information. And then there's also organizations, you probably have heard of them, like FHE.org, for example. They are also a very good centralized repository of information. I've given a talk to FHE.org. That was a few years ago, but you can still find that on YouTube. And then also there's people like homomorphic encryption.org. We are also a participating member of the Fully Homomorphic Encryption Technical Consortium on Hardware, which goes by the acronym of FHE. So we are a participant in that as well. So we will also be contributing to things like draft hardware interface standards. So all of this is really trying to take the nascent hardware space, take the nascent FHE space, and give users something akin to sort of like the way that you would expect to work with a GPU or a CPU in terms of architecture, something stable, something consistent that captures the needs of what you're trying to do. And on top of that, you can build the solutions, you can build the libraries, you can build the tool chains that will make all of that run the way that existing computers do, which is where most of it is below the surface and you don't need to think about it at all. That's the long-term goal for what we're trying to do in terms of the actual physical hardware. So if you go to optalysys.com, if you go to the Innovation Lab, you will be able to sort of stay up to date with what we're doing in this space.
We've been making some different posts sort of explaining different FHE things. I think that's one of the great things about the FHE community, that there's a lot of sort of explainers and people trying to communicate the ideas. So from especially the FHE.org, some of the talks there and some of the resources they have, sort of taking things from the academic interest groups to the developers, to the other people. I think this is one of the things where, you know, you can make something really good. Like FHE is a really cool technology, but if you cannot communicate clearly to people why they should use it or what it is or anything about it, then they're not going to be able to take advantage of those things. So hopefully, I mean, even just like the podcast here is helping people to understand a bit more about the technology and sort of maybe see some use cases and things that they could do to get involved.
Yeah, for sure. And I mean, it was a really good discussion for me. And like, I mean, it was like the first experience for me to like have more than one guest. And I was just a bit nervous, like how to, how to deal with, two people with different, like both experience and also like, working field, like different titles. But it was a really fun chat for me. And like you guys were extremely positive. And like, thanks for being here with me today and like being in the FHE Onchain podcast. I would love to hear if you have some final words before closing up.
Certainly. Thank you for having us, first of all, Furkan. It's really exciting to see the state of the field, to see in 2025 just what is actually happening around the use of FHE. You have a lot of different products launching. You have the first hardware. You have a lot of different emerging opportunities. It's where FHE is making that transition from something that was still somewhat academic to an actual production environment. And there's a lot of learning. There's a lot of opportunity there. And so events like this, podcasts like this, and of course you've got things like ETH Denver later this week, really, really important for this space. There's a lot to be said. FHE has these kind of fractal dimensions where you find it can be used almost everywhere, but it's building towards that shared understanding. It's building towards that shared awareness of what it can do and how to leverage it, that things like this are really important for. So thank you very much. Erin.
Yeah, thanks so much for having us. I really appreciate the opportunity to sort of talk about FHE. And yeah, it's nice to be able to do, like Joe said, this kind of communication with maybe a different audience, some folks in the blockchain world learning about FHE for the first time. And hopefully finding more avenues for which it can be used that perhaps we haven't thought about yet. So excited to see where things go.
Yeah, totally excited. And once again, thank you for being here. And I'm hoping you guys a great journey like in this process and like making FHE great again. Let's say that was the slogan, right? I hope we'll see way more faster implementations and great use